How ironic would it be if the water you drank to take your medication prevented the metabolism of that medication in your body? I'm talking about water pollutants. These pollutants start out as chemical ingredients in paints and plastics, everyday products that you and I use. But over time, these products break down, releasing these chemicals into air and water sources. Now as pollutants, they've been measured all over the world, including locally by the lab I'm a part of. But because these are an emerging class of pollutants, they aren't regulated, and we don't know what risks they pose. So I'm interested in understanding how these pollutants affect the enzymes important for our metabolism. Our enzymes do more than just break down food we eat. They also break down medication. However, it's important that we don't overload these enzymes with too much to process at once. For example, you know it's a bad idea to take Tylenol for a headache after you've been drinking. And that's because both Tylenol and alcohol rely on the same types of liver enzymes to break them down. So when we consume both at the same time, our enzymes get overwhelmed, shut down their normal processes, and end up creating toxic byproducts. My question is, do water pollutants also overwhelm our enzymes in the same way? To answer this question, instead of waiting to see what happens to people, I study how zebrafish metabolize these pollutants. Zebrafish are a well-established animal model that are really useful because their enzymes function similarly to ours. Under a microscope, I'm actually able to look in real time at this enzyme activity. In these images I've taken of zebrafish midsections, up top, lit up in red, you can see this enzyme activity. And they're just doing their job to process a substance I'm using as a control. But what I'm finding in this bottom image, when I add in a water pollutant, these enzymes shut down, similarly to that Tylenol-alcohol combination, leading to some unhappy fish. Disrupting these enzymes not only affects their ability to process things that we have control over, like a glass of wine or beer, but we actually depend on these enzymes all the time to process things that we can't control our exposures to, like air pollution we breathe in as we walk down the street. Here's a fact. The FDA estimates that adverse drug reactions are the 4th leading cause of death in the US. But could interactions with water pollutants be overlooked in this statistic? Ultimately, if we can better understand the risks that these pollutants pose, then regulators will be more informed in their decision-making, and we won't have to think twice when we reach for that glass of water. Thank you.